In this video, we are going to learn about complex numbers. First, we define complex numbers. Complex number is a combination of real numbers and imaginary numbers. Real numbers are also subject of complex numbers. We use capital C letter to denote complex number set, and the real number is a subset of complex numbers. So all the real numbers we can belongs to the complex number set. Usually we use simple C, W and Z to denote a complex number. There is a general form of complex number and we denote it as Z equals A plus BI, where A and B are the real numbers and I squared is defined as -1. So this is the general form of a complex number. So as the definition, complex number is a combination of real number and imaginary number. We denote real part of the Z as REZ. This means real part of Z. So according to the general form, real part of Z equals to A. And we use notation IMZ to denote imaginary part of the Z. So according to general form, imaginary part of Z is B. Then we are going to locate a complex number. So we can locate complex number in a Argand diagram. Argand diagram is a plane which has two axes called real axis and imaginary axis. We can locate any complex number in an Argand diagram. So I'm going to draw an Argand diagram. It is just like our xy plane. So in our x axis we call this as, in Argand diagram we call it as real axis, and y axis we call it as imaginary axis. So I'm going to locate my complex number Z equals A plus BI. In this Argand diagram, I use condition A and B greater than 0. Then I can locate it as this. So this is my complex number. Real value equals to A and the imaginary value equals to B. By using the Argand diagram, we can denote the modulus of complex number. Modulus of complex number is defined as length of the line connecting origin and the complex number. So we know that origin is here 0, 0 point. So the modulus of a complex number is the length between line connecting origin and the complex number. So as the definition, I can draw a line connecting complex number and origin. So the length of this line is the modulus of Z. So we use notation modulus Z to denote the modulus of a complex number, and we can find this length of the line using Pythagoras theorem. We know that this length is B and this length is S. Using Pythagoras theorem, we can write that modulus of Z equals to A squared plus B squared square root. Then we can talk about the argument of a complex number. Argument of complex number is defined as angle between positive real axis and line connecting origin and complex number. So argument of Z is a angle which described by which between real axis and the line connecting origin and the complex number. We call this angle as a argument of Z, and we denote it as ARG Z, and I can write it as theta. It is always an angle. So we can, in the problem solving, we can find this angle using our trigonometry knowledge. Then we're going to look at the complex conjugate of a complex number. Complex conjugate of a complex number is defined as mirror image of the complex number on real axis. So according to the definition, mirror image of Z, I can locate it as here. On x-axis I can locate it as here. So we denote complex conjugate of Z as Z bar. As you can see, the real value of a complex number remains same, but the imaginary value of the complex number change its sign and take its negative b. So I can write the complex conjugate of x z as a minus bi. As you can see, z equals a plus bi, and complex conjugate is z bar a minus bi. So the sign between the real part and the imaginary part change when you get the complex number and its conjugate. If you know the complex number, you can find its conjugate really easy. You just have to change the sign between real part and the imaginary part. So these are the basic things you have to know about complex number. In next video, we are going to look mathematical operations of complex number. See you in next video.